Assalamu alaikum. My name is Hazar Sajjad and my group member is Muhammad Ali Raja. The topic assigned to us is pipelining in computer architecture. So let's begin. What is pipelining? Pipelining is basically a process of arrangement of hardware elements of the CPU such that its overall performance is increased. Pipelining is an implementation technique where multiple instructions are overlapped in execution. In pipelining, more than one instruction is executed. Execution of more than one instruction means parallel processing, which makes processing the overall system more efficient. So why we need pipelining? To improve the performance of a CPU, we have either two options. Number one, improving the hardware by introducing faster circuits, or number two, arranging the hardware such that more than one operation can be performed at the same time. Since there is a limit on the speed of the hardware and the cost of faster circuits is quite high, we have to adopt the second option. For this purpose, we use pipelining. Our teacher once gave us a very simple and useful example to understand the concept of pipelining. Let me clear the concept with that example. In a car manufacturing plant, if a car is being made in steps, for example in first assembly, the workers install the body kit, then in other assembly, engine is installed, and in this way other components are installed in their individual units. It will take more time to complete a car. If the same company works on the different parts of the car simultaneously at their respective units, the factory will generate more cars in less time overall. Same happens in pipelining. When more than one process occurs simultaneously in parallel motion, making the execution time almost equal to its half. Thus, pipelined operations increases the efficiency of a system. Now we will discuss the design of a basic pipeline. The basic pipeline design includes input, output, interface registers, clocks, and the stages. In a pipeline processor, a pipeline has two ends, the input end and the output end. Ends are connected with multiple stages, or you can say segments, such that output of the one stage is connected to input of the next stage, and each stage performs a specific operation. Interface registers are used to hold the output between the two stages. These interface registers are also called a latch or a buffer. And there is a common clock which controls all this functionality. Now coming to the pipeline stages. There are 5 main stages of the pipeline. Number 1, fetch. 2, second. Decode, execute, access, and write back. In fetch, the CPU reads instructions from the address in the memory whose value is present in the program counter. In decode, instruction is decoded and the register file is accessed to get the values from the registers used in the instruction. Number 3, in execution, ALU operations are performed. In memory access stage, memory operands are read and written from the memory that is present in the instruction. In the last stage, the computed or the fetched value is written back to the register present in the instruction. Now coming to the performance and the calculations in pipeline. On the right side of the screen, you can see the performance difference between a pipeline and a non-pipeline processor. In pipeline processor, the multiple instructions are executed simultaneously rather in separate formation, which shows that you don't have to wait for an instruction to complete. Rather, you can get the result at the same time, making the overall time less. At the left side of the screen, you can see the two main formulas of the pipeline and the non-pipeline processor. These formulas shows the execution time of the instruction in a pipeline and a non-pipeline processor. The number 1 is for pipeline and the number 2 is for non-pipeline processor. In the formula, the K represents the stages of the pipeline, N represents the number of instructions, and the TP is one stage time. If you put the values in the both equations, the result will be quite sure. The overall time from the first equation will be almost as half as compared to the second one. Finally, and most importantly, we will discuss pipelining hazards and the solutions. Hazard is a situation that would cause incorrect execution. Or you can say if next instruction were launched during its designated clock cycle. There are three types of main hazards: structural, data, and control. There are two causes of structural hazards. Either it can be caused by hardware resource contention, and number two, using same resource by two instructions during same clock cycle. Data hazard is caused by an instruction may depend on the result of the prior instruction still in the pipeline that did not write back its result into the register file. And finally, control hazard. Control hazards are caused by two main effects: caused by instructions that change control flow, and number second, delays in changing the flow of control. So the main thing is how we can resolve these hazards. Hazards are a serious issue in pipelining, and they can be eliminated with careful designs of the pipeline. There are two main solutions to these hazards. Solution number one, we can delay the access to hardware resource, or number two, we can add more hardware resources. So now we know the main concepts related to pipelining in the computer architecture. That's all from our side. Thank you for watching. Allah Hafiz.